Hey, good evening. It's Chris Potter. It is May 25th, 2017. I have an article from skyandtelescope.com you might be interested in, titled Gravitational Lensing Reveals quote-unquote Iceball Earth 13,000 light years away, written by Summer Ash on May 4, 2017. Astronomers have discovered an iceball Earth orbiting a star 13,000 light years away. Multiple eyes on the sky have revealed some of this world's little secrets. NASA's Kepler spacecraft steals most of the exoplanet thunder these days for its prolific catalog of planetary discoveries. But beyond Kepler's reach are planets such as OGLE-2016-BLG-1195LB, an iceball Earth more than 13,000 light years away, the same distance from its star as we are from the sun. OGLE stands for Optical Gravitational Lensing Experiment, a ground-based telescope in the Atacama Desert run by the University of Warsaw, Poland, that's dedicated to finding and following microlensing events, a gravitational lensing phenomenon that occurs on small, even planet-sized scales. Microlensing occurs when one star passes in front of another, more distant star, seen along the same line of sight. Let's read that again. Microlensing occurs, pardon me, when one star passes in front of another more distant star, seen along the same line of sight. The mass of the closer star lenses the light from that more distant star, which appears to brighten over the course of hours to days to weeks. Since microlensing is transient and relies on precise alignment, the best way to catch an event is to survey a huge area on the sky, densely packed with stars night over night. So OGLE monitors the brightness of hundreds of millions of stars in the Milky Way's central bulge and the Magellanic Clouds, okay, on the right, okay, so in this cool little graphic. In a microlensing event, a foreground star passes directly in front of a background star, okay? The background star's light bends around the foreground star, all right, which gravitationally lenses and magnifies the starlight. Magnifies. Yeah! The background star's light bends around the foreground star, which gravitationally lenses and magnifies the starlight. If a planet orbits that foreground star, it too will leave its own little mark on the background star's light. The exact shape of the blip in the light curve often looks rather complex depending on the nature of the system. Interesting that we're discussing this today, don't you think? While OGLE's primary mission is to probe the nature of dark matter, the microlensing events it finds can also reveal the presence of planets. If the intervening, pardon me, lensing star has a planet, it creates a shorter secondary brightening of that distant star. In fact, while Kepler was best suited to finding planets closely orbiting their stars, OGLE is better suited to finding planets farther away from their stars, thanks to the geometry required for lensing. The newest discovery, again, pardon me, is OGLE 2016 BLG 1195LB. In late June 2016, OGLE detected the telltale brightening of a microlensing event and sent out an alert requesting several other facilities to observe it simultaneously. Both the ground-based Korea Microlensing Telescope Network, KMTNet, and NASA's space-based Spitzer Telescope jump on board to monitor the event over a course of a month. At the time, astronomers didn't know about the presence of a planet. It was only when analyzing the data after the fact that the team saw its signature. For its part, OGLE alone can only measure the ratio, pardon me, of the lensing star's mass to the mass of its planet. It was the additional data from KMTnet and Spitzer which created a sort of stereoscopic vision. Think classic Viewmaster. That enabled astronomers to calculate the mass of individual objects in the system. It turns out the newly discovered planet is not only roughly the same mass as Earth, it's also in roughly the same orbit around its star. But while we lie in our sun's habitable zone, OGLE 2016 BLG 1195LB lies so far beyond the habitable zone of its smaller star, it's likely a permanent ball of ice. If you've ever wished for winter all year round, this is the planet for you, boo. OGLE 2016 BLG 1195LB, the star itself is only 7.8% the mass of our sun, or just under 100 times the mass of Jupiter, which puts it in the gray area between red dwarf stars and brown dwarfs. What? Red dwarf stars, dude, yeah! There's a whole plethora, a whole rainbow of these goos. And they emphasize, okay? Look at this. I find it credible information because the physicist has said the same thing. Okay, if it's just a principle of physics, great. I find it ironic that I keep coming across little nuances in these articles. There's a reason I'm putting these articles out. I'm not saying why I'm doing what. I don't think you guys... I think those of you that have really followed me and understand what I'm doing, they get what's happening with me and what I'm trying to do. Let's just leave it at that, okay? So let's read that again, because I thought the red dwarf star was kind of cool, dude. Okay, between a red dwarf star and a brown dwarf, again, which are too small to fuse hydrogen. She always says that, okay? And I know that we've read other articles from these websites in the last couple weeks that have said the same thing regarding brown dwarfs. So I'm trying to repeat the information, kind of. Okay, anyway. That means that not only is it always winter on this iceball Earth, it's dimly lit, a dimly lit one at that. The artist's conception shows OGLE 2016 BLG 1195LB, a planet discovered when the star it orbits microlens the light from a background star. That was a good explanation of an overall explanation of this article. Okay. Listen to this is kind of interesting. Given that red dwarfs are the most common type of star in the galaxy. Wow. What? I didn't know that. The most we can learn about their likelihood to host planets, the better we can try and understand planet formation. Red dwarfs. Okay, you heard it. SkyandTelescope.com. You didn't hear it from me or the physicist, man. And I didn't say a brown dwarf. I said a red dwarf. Given that red dwarfs are the most common type of star in the galaxy. Red dwarfs, that's the new thing we're going to start talking about. The more we can learn about their likelihood to host planets, the better we can try and understand planet formation. Cool. We still don't have a very good idea of how a star's environment, presence of its binary companion, density of nearby stars, intense radiation from stellar neighbors, etc., might affect its ability to host a planetary system. Projects such as OGLE, which focuses its observations on denser environments like the galactic bulge, could help address the question of whether or not the frequencies of planets in the disk of the Milky Way differs from the frequency in the bulge. A recent study of 20 OGLE planets suggests that the planets might be less abundant in the bulge, but the question is far from resolved. Interesting question. Stereoscopic observations of each new microlensing event with Spitzer and even Kepler in its K2 phase could shed a lot more light on the issue. I will put the link below Look, man, thanks for watching and subscribing. Thanks for dealing with me. You have a wonderful day. Take care, my boo.